Okay, this is section 5.4, and we're going to divide this section into two different parts. So this first part is we're still kind of talking about inverses, just like yesterday, and we're going to be finding the derivatives of the number e, or e to the x. Okay, so the first thing we're going to talk about is the definition of the natural exponential function. Let me get my pen ready here. So the inverse function of the natural logarithmic function, f of x equals natural log of x, is called the natural exponential function, and is denoted by, this is my inverse symbol. So the inverse of natural log of x is e to the x. Okay, so that is y equals e to the x if and only if x equals natural log of y. And we know that because, remember, we switch our x's and y's to find the inverses. Okay, so the first thing we're going to do is some basic Algebra 2 skills, because you're going to need these in order to solve some of the problems coming up. So we're going to be using properties of logarithms and properties of our e to the x in order to solve some of these problems. So example 1 says solve 7 equals e to the x plus 1. So my hint is if I'm solving for x and x is an exponent, I need to be able to bring that exponent down into my problem. And the way I'm going to do that is by using properties of logarithms. Now here's the problem. I don't have a logarithm in this problem. Okay, but I can log both sides so that I can use the properties and bring that exponent down. So here's what it's going to look like. And one other thing that you might keep in mind, natural log of e is always equal to 1. Okay, so the first thing I'm going to do is I'm going to take the natural log of both sides. So the natural log of 7 equals the natural log of e to the x plus 1. So now I'm going to use the properties of logarithms on this right-hand side to bring this exponent down in front. So I have natural log of 7 equals x plus 1 times the natural log of e. Well, we already know that the natural log of e is 1, so now that goes away, and I have natural log of 7 equals x plus 1. If I'm solving for x, I'm going to subtract 1 from both sides. Now you have to be careful because when I subtract 1 from both sides, it doesn't mean I can subtract 1 from the 7 and get natural log of 6. That's not right. So I can either write it as negative 1 plus the natural log of 7, or natural log of 7, I just need to make sure that's separate, minus 1. Okay, and then if I put this in my calculator, you should get something like 0.946. Okay, and that's a basic Algebra 2 problem, but just in case we have forgotten, we're going to be using those. Okay, so example 2. Solve natural log of 2x minus 3 equals 5. So in this problem, I'm still solving for x. Here's the thing though, my x is not in the exponent, so I don't need to log both sides. And in fact, I already have a log in my problem. Okay, so in this problem, I need to rewrite this in exponential form. Remember when I'm dealing with natural logs that my base is e, and that base is usually shown right here. So remember, if I have log base 8 of 4 equals x, another way to write that would be 8 to the x equals 4. Okay, that's just something I came up with. So a way to rewrite this would be my base is e. My exponent is always the number on the other side of the equal sign, so it's e to the 5th equals 2x minus 3. So now I'm going to solve for x. Add 3 to both sides, so I have e to the 5th plus 3 equals 2x. Divide by 2. So x equals e to the 5th plus 3 over 2. I can leave my answer like that, or if I put that in my calculator, remember you have an E button on your calculator. It's second division. X equals 75.707. Okay, and again, that should be review. All right, so let's look at the next thing. Okay, so this is just a reminder about operations with exponents. If I have e to the a times e to the b, I can rewrite this as e to the a plus b. Okay, so multiplication. Okay, if I have the same base, I add my exponents. Here, if I have e to the a divided by e to the b, if I'm dividing and I have the same base, I subtract the exponents. All right, so that's just a little reminder. And here are our new derivatives for today. Our new derivatives, the derivative with respect to x of e to the x, and I know it seems weird, but it is e to the x. And the book goes through a long proof, well, it's not real long, but shows you how that works. It's on page 354. Now, sometimes I'm not going to have just an x there. I'm going to have something other than the x. So if I have the derivative of e to the u, it's going to be e to the u times the derivative of u. Okay, so let's do a couple of examples. Okay, this would be an e to the u problem, right? Because I have something other than x. So the derivative of this would be e to the u, 2x minus 1, times the derivative of my u, times 2x. And I would normally rewrite that as 2x e to the 2x minus 1. Okay, example 4. I'm going to find the derivative of e to the negative 3 over x. So this is an e to the u problem, and on this one I'm going to go ahead and write this out. If u is negative 3 over x, what's the derivative of that? Well, I would have to rewrite that as negative 3 to the x minus 1. So the derivative of that, bring down my exponent, so that's 3x to the negative 2. So couldn't I rewrite that as 3 over x squared? Okay, so I'm going to find the derivative. So the derivative of e to the u is e to the u times the derivative of my u. We just found that. So usually I would rewrite that as, now I know we have a negative exponent here. We're not going to try to fix that. We're just going to leave it. 3e to the negative 3x over x squared. And that's my answer. Okay, and we only have one more example that we're going to do today. Find the relative extrema of f of x equals x times e to the x. Okay, remember what relative extrema means. It's like maxes or mins. Okay, how do we find maxes or mins? We find maxes or mins by finding the derivative and setting it equal to 0. We would also find out where the derivative is undefined. Okay, there's no place that this is undefined. Okay, this is a continuous function. There's no asymptotes or anything like that. Okay, so I just need to find the derivative of this and set it equal to 0. So I'm going to say f prime of x equals. Now here's the deal. This is the product rule. Here's my first term. Here's my second term. So product rule says first term times the derivative of the second, which is e to the x, plus my second term times the derivative of my first. Okay, so there's my derivative. Now I need to set this derivative equal to 0 and solve. So 0 equals x e to the x plus e to the x. Now this is kind of weird. I have to solve for x. So the first thing I see is that I can factor out an e to the x. So I'm going to factor out an e to the x and write down what I would have left. Okay, so I have e to the x times the quantity x plus 1. So now normally we would set each factor equal to 0 and solve. Okay, well this one's easy. X would equal negative 1. This one, e to the x equals 0. Okay, e to the x, okay, if I were to graph this or look at the graph, what number could I put in for x? Remember, e is just a number. E is 2.7 something. So what number could I put in as my exponent so that I could raise 2.7 to that power to get 0? If I plug 0 in, e to the 0 is 1. If I plug 1 in, e to the first is e. E squared is just whatever 2.7 squared would be. Do you see that there's never a number that I could plug in for x that's going to give me 0? Okay, it doesn't exist. So this part I don't have to worry about. And there's a relative extrema at x equals -1. Okay, all right, that is it for tonight. If we don't have school on Thursday, I will post what the assignment is that you're going to be working on. Okay, I will, whoops, see you on Thursday.